Okay, good morning. So last class we have discussed about the Kubernetes services and its types, and we done couple of exercises, right? So today let's let's go through the one more important topic called the persistent volumes and persistent volume climb. So the persistent volume, in the sense, again, it's in the safeguarding the data uh, of your pods and so it's again a kind of, it's a piece of storage in the cluster that has been provisioned by an administrator or dynamically provisioned using the storage classes. And PVC is again, it's a request for storage by a user, or it is similar to a pod, and pods consumes a node resources, and PVCs consume a persistent volume resources. If you look at this difference, it is similar to pod. Pod consumes a node resources. In the sense, when you are creating a pods, it is gonna consume the nodes resources, right? That's how the architecture meant by. And the PVCs consumes persistent volume climb consumes the PVC, persistent volume resource. So that's what it means to say. And pods can request specific level of resources, CPU, memory, so like that. And clients can request specific size and access mode as well. So it has, some advantages over the PVs and PVCs over to the normal without the storage PV and PVCs. So if you go through one exercise, so that you will get an clear picture on how we are going to use the PV and PVCs. And again, here also I'm going to use one more. It is kind of, a small project. Uh, Create a HTTPD, create on Python project, and use a Kubernetes, using Kubernetes PV and PVCs, and also mm, one second. Also create a service of type notebook. Okay. And again, where we are keeping all the data, we are keeping in a Git. Maintain code in Git and GitHub. Create a Python project and maintain code in Git and GitHub using Kubernetes PV and PVCs, and also create a service of type notebook. Okay. So let me open Visual Studio Code. So this is Visual Studio Code, and navigate to the folder. Where is that? So under this Git repository, I have already created one couple of YAMLs. What it is going to do, it is creating one deployment called HTTPD deployment, and assign a storage volumes like this HTTP storage. That's called, here again PVC we are claiming like this HTTP PVC. Okay, PVC comes here, that part HTTP PV, and we are assigning 1 gigabyte of storage, and the read write access once persistent volume claim policy is retained. Mounted data is the path of your PVs. And in the same YAML, I'm creating one more uh, called persistent volume claim, and this is the name of the persistent volume claim, and I'm assigning the 500 MB of storage space. Okay, so just I wanted to change something. Um, Welcome to DevOps training, and welcome to my DevOps training. Okay, let it be. We will change after some time. Okay, so it is not accepting anything. One more exclamatory I am going to give so that it is going to track something. If you look at this, this is the placeholder for pushing the content. Um, Deployment HTTP sync changes, in the sense it is gonna sync with the main repository, Git repository. So deployment HTTP, just now I push it now. That's why it is showing now, and the commit message here it is showing, and this is a message we are given. Welcome to my DevOps training. So this is what we are going to demonstrate using the PV and PVCs, persistent volume and persistent volume storage. So let's go back to the um, instance Kubernetes instances. Let me start. Only connect master. That's it. We no need to connect nodes. Okay. Let me clone this repository to my. So this is the. If you look at the under code in my repository code, you will get a URL like this. Just copy this URL for the clone purpose. Git clone like this. So now you are going to clone the whatever the things you are defined under this folder. You got this. Just get into that folder. What is the name of the folder? Kubernetes demo Feb 2025. Kubernetes demo Feb 2025. CD Kubernetes demo 2025. Okay. So here there are two folders are there. One is deployment and one more is for PVC. Just get it to PV folder. So here is our files. Just cat cat httpd deployment. So this is, if you look at this message, the same message you got whatever we are given in the local machine. The same content I had pushed now. Now let's use kubectl -f kubectl create -f. First let's create a, or if you give random just dot also, it is gonna create everything instead of giving one by one. I'm giving just dot. It means whatever the files comes here, no, unless all it is gonna create kubectl apply, anything you can give, either apply or create also you can give -f, just give dot. So this is going to create a what is this saying, http service. Okay, let's see, anything is already running. Okay, just now it is created kubectl get dep get type deployment. Okay, this is also created. I mean, it got created long back. If you want, you can delete and recreate it. Kubectl delete -f httpd deployment. Okay, it is deleted now. Let's create it again, or apply also. You can apply. So it is gonna create a deployment now. How to check a deployment is created? Kubectl get deployment. Now it is created. See, and one more thing, kubectl get service svc httpd service. It also got created 3 days ago when I was trying to exercise, but not an issue. But if you want to recreate also not an issue. Delete -f. What is the file name? kubectl delete http service -f http service. So service got deleted. Again, you can create again. Okay, service also created. Now let's see, we are able to access this application outside. kubectl get all -a, so that it is gonna display all the information. So this is the pod it got created 106 seconds ago, and this is the service which it got deleted. I mean, created service http service. Node port is the type, and this is the port number we created, and namespace. So these are the namespace and the default we have created, and okay, this is replication set. That's okay. Now, um, how many replica set we have created? Only one, I believe. That's okay. We will let's try to access this application whether we are able to get or not. What is the port we have given? 30080. 30080. Yeah. Welcome to my DevOps training. So this is what we had given in the local system, right? Welcome to my DevOps training. Now I wanted to change little something so that I wanted to replicate how immediately we can take action. So currently how many parts we have? kubectl get pod. Currently only one part we have. kubectl get pod. So only one part it is running currently. That's what the replication set we are defined. I wanted to change to 3. Okay. And I wanted to change some message also. Training. Welcome to my DevOps bootcamp training. I'll message bootcamp. Okay. I'm going to put a message like this and the replication sets in the sense the number of parts I am planning to create 3. So how we are going to achieve this? Let's commit this one. Okay. I'm supposed to provide on deployment to commit message. What happened? Let's go back here. Let's see whether it is reflected in the Git. Still not reflected it. Let's see. Git add. Git. Git commit -m. Replica 3. Git push. Okay. Now all files pushed here. C replica is equal to 3 and DevOps bootcamp. Currently what we have only my DevOps training. Okay. Now how we are going to take action immediately. So we are not doing anything much. We are just very simple. We are trying to do it. kubectl. First delete the existing set. kubectl -f data. So it is going to first delete the existing things. All deleted. HTTP service deleted, volume deleted, and deployment also deleted. Claims. This is also nothing is there. Now first git pull. So it is gonna pull the latest commit, latest changes, and kubectl create. See how easily we are going to deploy the application. See deployment created, service created, permission PV also created, PVC also created. If you go ahead and refresh it, see, welcome to my DevOps Bootcamp training. So that's what we are defined here, right? In the local, welcome to DevOps Bootcamp training. And replication set I had given 3, right? Let's go ahead and check how many parts created now. kubectl get part. You supposed to create 3. See, 3 got created. See, very easily we are going to maintain the parts with the help of deployments and PV and PVCs. And also, if you going to terminate any part also unexpectedly, so the data is still persist in the persistent volume PV and PVCs. So that is the reason your data is in safe. Though if your parts are going to crash, so the data is still available to access outside like this. Got it, Sunil?
Yeah, got it.
Yeah. So if you look at the same scenario in the real, without containerization, Kubernetes, see how hard you are going to spin up all these servers again. Either it is a VM or servers. It is again a tedious job for the people, right? Platform team. So after utilizing the Kubernetes, just in a fraction of seconds, you are going to deploy your applications. So like this. So that is the advantages of making use of the containerization platform. So that is the reason the companies are migrating to these microservices, the Kubernetes services, so that easily scalable, secured way. The applications are fast. You are going to deploy the application in a faster manner. So that is the reason. Okay. What is the next topic? Increase. So we have a couple of topics. So I'm not going to give you any demonstration. I'm just giving you the high level, so that you are going to these are the advanced topics. Okay, you just aware of this. You don't need to do. If you get a time, just practice it, because already YAML files are available in the net, in the Kubernetes website. Okay. Ingress is again the latest load balancing technology. Um, there are some drawbacks in the existing services. So this Ingress is going to help you to load balance your applications like this. So Ingress is an API object that manages external access to the services within the cluster, typically HTTP and HTTPS traffic. So it provides a routing rules that define how external requests reach different services inside the cluster. Like when I say, if you're trying to access Amazon.com, so in the background there are ingress rules are in place, so that everybody's across the world the traffic is going to load balance to the each and every internal services in the Kubernetes. So that's what I mean to say. And I'm just giving some what is the comparison between ingress, load balancer, node port. So ingress manages HTTPS traffic using the ingress controller.
Okay.
And load balancer, it creates a cloud provider load balancer to expose a service externally. Like when I'm saying about this URL, this is in a public URL. It doesn't mean that the same URL you cannot provide to the customer side. So that is not the best practice also. We are just practicing purpose. We are trying to use, instead of creating any external services, we are using the IPs, but it's not the good practice to maintain this IPs outside, right? So that's what I mean to say. Load balancer create cloud providers load balancer to expose service externally. And node port exposes again a service on the static port on all nodes. Node port again, right? It's one more type of services which is going to expose a service on the uh, static port on all the nodes. I mean, it is going to expose the traffic to the outside the cluster. That's what it meant to say. And another topic called taints and tolerations. These are all the advanced schedulers, part schedulers. When I could say part scheduler in the sense the um, there are some you can restrict the nodes you are going to you should not go go ahead and land this so and so part on the so and so nodes. So those conditions you can apply through the taints and tolerations. So taints and tolerations in the Kubernetes are used to control which parts can be scheduled and which nodes. So we can specifically define this. If you have 100 no, sorry on 10 nodes you have, so you can define so and so projects parts going to schedule and so and so nodes only. So that condition we can apply with the help of this tech, taints and tolerance. So they help ensure that workloads are assigned to appropriate nodes, preventing unwanted schedulings. Right. So it is gonna prevent the unwanted schedule on all the nodes. So we can define, go ahead and land on the node 9 and node 10 out of uh, 10 nodes. And taint is applied to a node, marking it as unsuitable for scheduling unless a part explicitly tolerates it. It means we can mark any node as a taint so that it won't marking it as unsuitable for the scheduling unless the part explicitly tolerates it. So when create a one node as a taint, so that it is it is telling the scheduler don't schedule on my node until it is a specifically you have to action explicitly you have to define the in a YAML file you're going to there are some conditions you have to apply if you wanted to schedule a part on the taint node. So like that. So toleration allows a part to be scheduled on a node within a matching taint. Toleration in the sense again you can define, so this is my xyz is my application, xyz is my part sorry node. Go ahead and only land on the so and so node only, xyz node only. Don't create anywhere other nodes. So that's what it means, tolerations. Okay, one more next topic. Any questions for this one, Sunil? Taints or tolerations?
No, okay. Thank
Okay.
you.
Okay, so we'll move on to the next topic. Stateful set. A stateful set in the sense again, it's a one more topic, advanced topics in the Kubernetes. So it is a workload API object used to manage stateful applications. It provides a stable, unique network identifiers, persistent storage, and ordered, graceful deployment and scaling. It is ideal for applications that require stable identities and persistent data, such as databases and distributed systems. So it means if you go back to the node here, so if you look at this, have you seen any the this? So let me see if you look at the naming conversations of this part. I'm going to delete one part. So if you notice the next part got created immediately, whatever we have deleted. So there are some random numbers are going to create at the postfix of each node. So that is not the always is not the good practice so that if you are going to deploy on database application, if you are it is going to take the name like this, that is not the right way of defining the applications, especially in the database applications. So stateful in the sense it is going to create a ordered way of let us take this one an example. It's supposed to create a deployment 1, deployment 2, deployment 3. So like this, if you are going to delete this part, if you are again the Kubernetes supposed to create a part 3 only, HTTP deployment part 3. It should not define any other naming conventions. So that's what it means to say, the stateful set. So it is ideal for application that requires stable identities. It's stable identity in the sense like that. The naming should be in a proper way. So these are deployment names. So that the database application, it is easy to identify the load balancer to route the traffics. Okay. And config maps and secrets is one more topic. Config maps and secrets in the sense, suppose your applications, you are going to maintain some information like um, any volumes related information, parts information, service type of information. So whichever is the information which is not sensitive, you can define in the config maps, like the pod name and the database name, server applications name. So those are not sensitive, right? So that you can define those information in the config maps. Whereas, see, a config map is used to store non-sensitive configuration data in the key value pairs. And secrets in the sense, it is similar to config map only, but it is especially designed to store the sensitive informations like passwords, usernames, API keys, certificates. So those, the service, the sensitive information you are going to maintain the secrets, which is not, directly visible to the people. Again, it is a encrypted, you know, encrypted way it is going to store in the secrets, so that nobody can steal the informations. So that's what it means to say. And last topic, liveness and readiness are again a Kubernetes uh, or liveness and readiness props are crucial for the maintaining the health of availability of your application. So these props helps Kubernetes decide when to start, when to restart or stop sending traffic to a container. When I say, let's go back here. Suppose I did deleted one part, right? So who is monitoring this? There is a something is going in the background in the cluster. So who is going to validating continuously if any pod is not there? It is immediately it is gonna create a new pod like this, right? So who is doing all these things in the background? So the pod is continuously monitoring like this. If any pod is it ready or is it live? So those things are capturing like that. So liveness prop determines if the container is still alive and it is running and not stuck. If the prop fails, Kubernetes will restart the container. See, the Kubernetes itself, it is going to initiate to restart the container if it fails the if it is not alive, if it is in stock, it is going to restart in the background. So nobody is going to do any actions restarting the things. Useful for detecting deadlocks, hunks, or unresponsive applications. Okay. And readiness probe in the sense determines if the container is ready to accept the traffic. So again, the Kubernetes is going to check whether the pod is in the ready state and it is able to accept the traffic. So that's what it means, the readiness probe. If the probe fails, Kubernetes removes the pod from the service and finds until it passes. It means in the background, if the pod is not ready, so it is automatically going to remove it from the services endpoints of a service, so that it user should not get into the unresponsive pods, so that again a user feels that there is some issue in the background. That should not be happening. Useful for apps that need to be initialized, apps that need time to initialize, example database connections, cache warming, stuff like that. So it means if there is a data DB related applications are there, so these topics are very essential to maintain the whether the top pod is up and running or whether it is live or not. So those things, these topics plays an important role um, in the Kubernetes cluster area. Okay, I think almost where we came to end up the Kubernetes. And so as I said, so everything is, you cannot just by heart the things, and you no need to remember any YAML configuration. So everything is available in the net, or I'm keeping in my um, here only, so that you no need to worry about the, just go through once what is this part for, what is this specs, templates. Just have a look on this, so that you will get an idea, so you no need to by heart the things. So these are all the YAML files, which are the approved Kubernetes approved formats like this YAML files. uh, okay, any
By
questions?
this, we are completing Kubernetes, right?
Hmm?
By this, we are going to complete the Kubernetes.
Yeah, by this we are going to complete now. I'm just removing the because of this Kubernetes. So 1 second. So let me stop the screen so that I can explain.